So here's a tough one.
Okay.
What does trust mean to you in the context of autonomous drive?
The ultimate vision for me is when I put my children into an autonomous car and let them go without thinking to school. This will be the moment where I say this is the trust and the need which is necessary to say we are done with the technology, that we can live in this autonomous world and we can use our brains for thinking about new other challenges. I think this is not a linear development phase. We will need some disruptions. Just understand the complexity what our brain is continuously doing while driving in such a situation. This has to be replicated by software, by hardware, and there has to be major technology changes be done. One fundamental thing is you need to go new paths, and artificial intelligence is one of them.
Okay, so what is a software-defined car?
So a software-defined car for me is it's growing a lot of more functionality, which results in much more logic, which has to be integrated into the car. So the value of software is tremendously growing the value of a car in the future. On the other hand, it's a life cycle topic. And nowadays, the customer expects a car which starts its life cycle when you buy it. It is upgradable. It moves on with technology.
Is NXP becoming a software company?
No. Or I make an analogy to the mobile phone industry. Is a mobile phone vendor a software company? Probably no. But is there a lot of value add with the software components on, I think, your personal mobile phone? You can say yes. That's exactly where we are in the transition of the automotive industry and in the transition from NXP.
Sustainable solutions are never easy, especially if you look at autonomous or electric mobility. In Bucharest, Daniel and his team developed the software and tools that enable the high-level system design, which is needed for sustainable mobility.
Bucharest is full of energy, full of young people. But what I like most is the attitude in regards of being super motivated, being super proactive and helping us to solve problems and not wait that the problems come to you. The architecture in the car, which is currently implemented, is not sustainable. There are so many more functions, and these functions just can't replicate in more control units in the car, in more space which they use, in a bigger harness as the electric wires in the car. So think of a door module, and a door module takes tasks which were very separate. So in the past you had a wiring harness through the door for all of the functions, and they are now aggregated in one chip. That's the zonal architecture. The second one is the domain architecture. That means control units which were separate in the past, like a basic ABS system, one example, but the vehicle dynamics, combustion engine control units, they all merge into a domain. That makes it much easier for the software developer later to interact with these different functions. So what we do to enable our customers to handle this complexity are different things. We are abstracting with software complex hardware accelerators as one example, but we are also developing tool chains, like for example model-based design, which simulate and emulate environments, which then make it very easy for the customer and their engineers to just develop the algorithm.
So if we spend a minute talking about the S32G, what is special about this flagship device?
It covers the domain of what we call networking and security. Another one is the connectivity to the cloud, to exchange data in a fast way, and to security. You want to make sure that you are connected to Amazon Web Services, not to somebody else.
The S32G covers safe and secure networking and gateways. It is also a great example of hard and software enablement. Many features from industry partners are pre-integrated on the board. AWS, for example, make edge-to-cloud services easier.
Hello, Bill. I am super happy to talk to you. For us, we are coming from the automotive industry. The car is getting kind of a vehicle edge device and is generating tons of data. How do you see it from your perspective? How does our customers benefit from this collaboration between NXP and Amazon?
Well, both companies are very focused on security and scalability and reliability. Also, the ability to push ML and IoT connectivity in the car, have cloud-native applications in the car, and be able to do big data at the back end and really build out this software-defined vehicle.
I think also one point which is very important is make it much easier for our customers to take our technologies. What is your perspective on this?
I think that's going to be really important there. Over-the-air updates have to be simple and secure. The pre-integrated ML pushed at the edge has to be simple and secure. As cars become, where processing power gets to be more important than horsepower at the edge, that's going to change the way customers look at vehicles and what kind of applications to generate revenue automotive manufacturers can build and added features to the cars. And I think that's really exciting in the work we're doing with the NXP S32G with its built-in security hardware and its backup accelerator and low power processing. That's going to make a big difference for our customers. I think that's really going to be paramount, is us making it easy to be secure and easy to connect.
There is no software with zero defects. Zero defect software doesn't exist by its nature.
What is it about first time right? What do you mean by that?
First time right is such a complex topic because it's not only about investing in early detection methods to make sure that we get the product fast on the market. It's important that we have the right quality in place and the product do what they're supposed to do. Quality is the foundation for everything that we do. NXP delivers microcontrollers, microprocessors together with software. All these are running in cars.
So what's the magic that you're doing? What's the trick?
So what we are doing, there are two tricks. The first trick is, as I said, we have to reduce the size of what we call the logic and the artificial intelligence networks. And so far, we are compressing them. We are running them through an engine which analyzes where we could reduce the net to 1/10 of the original net and not losing a lot of accuracy. For example, in object detection, if you have an algorithm who runs on a very high CPU power machine, has a 96% accuracy to detect an object, if you reduce it, you probably have a 95% accuracy, but it still runs on an embedded system, which is probably 1/10 of the cost, very friendly in regards of power consumption. That is one piece of the magic. The second piece is it still has to be fast, right? You need a lot of hardware acceleration. So once you have compressed the net, it has to work in runtime on a highly efficient system. And that's where we adopt and also analyze the algorithms and put it on hardware accelerators, which massively speed up the computation time. There's a lot of energy put by companies into the direction of optimizing the algorithm, but there are not so many companies who are doing the adaptation to the embedded world. And that's where we are playing. I think with using the terminology software-defined car, there's a misunderstanding in the industry. Everybody thinks more software makes more software relevance in the car. But what we mean with software-defined car is that the software shapes the ingredients of a car, which includes all kind of hardware, but also software.